Okay, for section A, verify simulation. After have downloaded the virtualization software virtualbox and already download the Raspbian OS, we will load the Raspbian virtual image and click new. Load the Raspbian virtual image and create Pixel, Linux and Debian 32-bit. After that, I will click start. And after it has start, set up the GPIO emulator by pressing the terminal icon here and type this file. After that, write this file to unzip the file. First, we'll start with new and type the Pixel 2. Change the type to Linux and version to Debian 32-byte. Then next, to memory size, hard disk, the hard disk file type, and then storage on physical hard disk dynamically allocated, and then we create. So here, if you type memstep as a command with no parameters, it will show you a set of value. These value are the average for each of the statistic. Since your computer was the last reboot, this figure are not a snapshot of the value of right now. There are a list of data item in each of the column. So as you can see, SWPD amount of virtual memory, in other words, how much memory has been swapped up. So it is 0. And currently unused memory is free. You can see there's a number, and buff amount of memory used as buffers, cache, the amount of memory used as cache. So C, the amount of memory that is swapped per second, and it is usually 0, the amount of memory. So it's a memory of KB swap up per second, also usually 0. Is a number of block read from block device per second, and here it should be a number of block written to block device per second, and this should be a number in system interrupt per second, and this number of contact switch per second. This is the percentage of time the CPU is spending on all non-kernel process. This is the percentage of time the CPU is spending on a kernel process, and here the percentage of time the CPU is idle, and here is the percentage of time of the CPU is waiting for I/O operation to complete. After that, the interval parameter is given in second. If an interval parameter is given, VM state continue to post and update at each interval as long as you let it run. Output from VM state may be redirected to a file to keep or save the data for later analysis. Okay, now I will type VM state 3 3 4. Okay, as you can see, uh, uh, it will provide an update every 3 seconds, but only up to 4 update. After the 4 update, the VM state will start on its own. Same if we choose VM state 2 3 every 2 seconds for 3 update. 1 2 3 and stop on its own. So now I will leave the VM start running while open and close application window and watch what happened to the numbers. Okay, for now we can see this number. Now we will see the difference. As you can see that I have highlight here, there is a different this here and here. There are only 3. That's the difference. So after that, we choose Raspberry Pi programming, and then Python 3, and then after we will choose file and new file, and we will search for the coding that we unzip. And after we found the coding, we just run it.
For section A, we use from emulator GUIM, import GPIO, and then import Raspberry Pi GPIO as GPIO. And they will display GPIO in emulator. After that, we import time, trackback, and request. Next line, we define the main of the program. It's like this. The function of GPIO set mode is to identify the number of pins that will be used. And for GPIO set warning, to get a warning in system if false. We set up pin 4, 17, 18 and 21 as output, and the initial value we set as low. However, for pin 23, 15, 24 and 26 as input. However, for pin 23, 15, 24 and 26
as
as
an
input.
input, which pull up down indicate we press the button. Then we use while function.
Then while
For
for
the
true.
first part, we set input
We set up
we set if
if input
input
for pin
23 equal
23
to false,
equal to
the
false,
output 14 and
the output
17
at pin
going
4
high,
and
which is
17
1.
will be high.
And if
Then
input
if
15 is
input
true,
for
the
pin
output
15
18
is
and
true,
21
the output
is
at
going high,
pin 18 and
which
21
is
become high.
1. And lastly, the input 26, if
Next,
the
if
input 26
input
is
for
true,
pin 26
the,
is true,
the GPIO output
the
4
output
and
at
17
pin
is
4
going to
and
low, which is
17
0. And the
become
time
low.
sleep is used to
And
delay
for time
execution
sleep, we
for 1
put time
second
sleep
for
for 1
each
second to every each
if function.
functions.
And then we use accept exception as
Then
X function
exceptions
so
as
that other
EX
pin,
and
other
trackback. When
GPIO
we put
pin
trackback
not
prints,
involved. And we write traceback the print the underscore ESC, and finally GPIO dot clean up, which is
and
this
finally we
ensure
clean
a
up
clean
the
exit.
GPIO.
And for the last
And
execution
for the last
we
line
write
we put
main.
main. This is the output and result from section E, with GPIO pin 15, 23, 24 and 26 as input, and for pin 4, 17, 18 and 21 as output, which the value is low. When we click GPIO pin 15, the output is GPIO pin 18 become high, and same goes with pin 21 become high. Then when we click GPIO pin 23, pin 4 and 17 will become high. Next, when we click pin 24, nothing will happen because we don't have any condition for pin 24, except for we declare 24 as input. Finally, when we click pin 26, the pin 4 and 17 will become low.
The Vikram asked question about Raspberry Pi. Number 1. Can Raspberry Pi be used as audio or video input? The answer is Raspberry Pi cannot be used as audio or video input in the basic version, but it can be successfully used as an audio and video input if the appropriate accessories are connected to the input. The device has interfaces that allow video recording via the camera module. Number 2. Where is the on-off switch located? There is no physical on or off switch on the Raspberry Pi. The device needs to plug in to be activated. It needs to be locked out from the main menu to disable the board for the desktop environment. On the other hand, sudo halt -h is typed at the command line and wait until all the LEDs except the power LEDs have gone out. It takes about 1 to 2 seconds for the memory card to finish its work. Then the device can be safely turned off. The important note is that improper shutdown of the Raspberry Pi can damage the memory card. Number 3. Can Raspberry Pi replace a computer? The Raspberry Pi 3 can replace a computer for simple tasks that do not require much processing power, while the fourth version of the popular Raspberry Pi is for more complicated operations. A model with a built-in 4 GB RAM has smooth operation, which in combination with a powerful processor that ensures more comfortable use, such as for web browsers. Number 4. Is it possible to increase the RAM? It is not possible to increase the RAM. Additional RAM cannot be installed in any version of Raspberry Pi. This is due to the design of the boards and their ability to handle memory. It cannot be disassembled, removed, or replaced with another. It is better to choose the fourth version of the device with the maximum available amount of RAM, which is 4 GB if the Raspberry Pi is needed for more complicated tasks that require more processing power. Number 5. Why is Raspberry Pi running slowly? All Raspberry Pi models run in what is called idle mode. The more the device is loaded, the higher the clock speed. The clock power is automatically limited when the processor temperature, which the specific value is different from each model, reaches its maximum value. This is an extremely important thermal protection, which protects the board from overheating and thus from serious damage.